A person walks down the aisle of a warehouse holding a large box. Shelves on either side of the aisle are filled with various items. Figure 13. Warehouses like this one require complex systems to manage their inventory. Microsoft Access is designed to handle and report on large amounts of data. Credit: Modification of Man Standing in an Aisle of a Warehouse Carrying a Box by Tiger Lily /Pexels, CC0. Chapter Outline. 13. 1. What is a database? 13. 2. Microsoft Access Main Features and Navigation. 13. 3. Querying a database. 13. 4. Maintaining records in a database. 13. 5. Creating reports in Microsoft Access. 13. 6. Creating forms in Microsoft Access. Welcome to the Business Analysis Department at WorldCorp. We are happy you will be working here. Your role as an analyst is to work with data professionals who support various teams within WorldCorp. Most of the time, you will be tasked with supporting the sales and marketing team, though you may also work with data from other areas of the company. To get started, you will learn what a database is and how to use its data, maintain its records, and create data reports. We focus on Microsoft Access in this chapter, but other database programs have similar features and functionality. Learning objectives. By the end of this section, you will be able to discuss how databases are used in organizations, compare and contrast the features of a relational database system with other types of databases and data storage, describe the objects in a relational database, evaluate applications of relational database management systems in organizations. Data, bits of information about people, places, and things, is a key part of the world of business and technology. It can take the form of words or numbers and is frequently collected without active individual involvement. For example, the internet is constantly collecting information on what consumers look at, click on, and read. This information is then often passed on to a database or even parsed out to several databases. Other technology, including sensors and the so-called Internet of Things, is also constantly recording and storing data for businesses to use in a myriad of ways. One of the challenges of managing and analyzing data is understanding what data is, what it can be, and how it can transform the world around us. Data on its own is not valuable or actionable. To make a difference, data needs to be processed and organized to give it context. When this occurs, we have information. Then, knowledge is generated from data that has been transformed into information and then finally analyzed in a way to give meaning and draw conclusions about the data. No matter how much data is collected, it is useless without organization and structure. Think about all the things you interact with in a typical day. If those things were collected but had no structure, imagine bits of paper with single words or numbers thrown into a pile, you would not be able to make sense of them. Since the value of data lies in its ability to inform decisions and help us understand the world, both past and present, the structure and storage of data are critical. A database stores a large amount of data in an effective way that will allow for efficient retrieval in a computerized environment. Databases may be physical objects, such as address books or file folders, each of which provides a place to keep data in an organized fashion so we can quickly locate what we need. Physical storage has limits, however, because its structure is easily overwhelmed when datasets get too large, and retrieval of meaningful information becomes impossible. A digital database is a computerized file that not only stores data in a structured or organized way, but also allows users to make changes to transform data. Digital databases are often contained within a program such as Access on a desktop computer or Microsoft Azure or in structured query language, SQL Server at the company-wide level. Digital databases add new features and capabilities to business decision-making by combining the power of analytics with the structure of tables and rows. Mac tip. Access is only available on desktops and laptops with a Windows operating system. It is not available on Mac, Chrome, or Linux devices. Mac has a comparable desktop-laptop database called FileMaker. Digital databases provide structure, organization, and access. But unlike physical objects, they provide a flexible structure that enables us to capture, store, and organize large, complicated sets of data, and that also gives us options for retrieving and using information. Using digital databases enables users to transform data, creating new ways of informing decisions. Because businesses must make decisions based on data every day, the key to good decision-making is creating a database that contains accessible, organized, actionable data. The role of databases in an organization. Databases drive nearly all business functions in organizations throughout the world. Any business that uses the internet has a digital platform or foundational technology that is built on databases. A digital platform is a place where users can interact with and explore the products and services offered by a company. Digital platforms often come in the form of an app, website, or social media. The term database is ubiquitous in organizations, where you can assume that every function and every employee or customer are interacting with many databases. Organizations use databases to store information about customers, employees, vendors, products, supply chain, transportation, maintenance, sales, inventory, and much more. Anywhere an organization is working with data, some type of database will be involved. Often the database is the foundation for the work, and the people who interact with the database may not even be aware that it is there. Data in organizations comes from a variety of inputs, such as from direct input by employees or customers. Some examples include entering new customer information, recording human resources information, creating maintenance requests, purchasing goods for company use, and engaging in sales transactions. Data can also come from technology that records information related to the business. For example, technology that tracks items such as inventory levels, building management, temperature, air quality, occupancy, traffic patterns, employee use of resources, resource use by customers, and customer contact, frequency and method of contact, as well as the results. Sales and marketing departments collect a great deal of data about their operations and customers. In addition to typical customer information and sales history, a business is also likely to look at daily performance data on marketing and sales operations. This can include sales force performance, customer service and experience data, social media promotion, and web platform performance. Automatic data collection tends to generate a very large quantity of data that needs to be connected or related, and then aggregated or summarized to be understandable and useful. Businesses also capture public data from other sources. For example, sales and marketing departments need to look at public data, which is available from the government and other organizations. Public data includes demographics and financial information and may even include climate change and environmental data that affects how businesses work. These datasets are free, very large, constantly changing, and challenging to locate and use. A clear plan for identifying and using this data benefits a sales and marketing department. All of this data has to go somewhere, and that is the digital platform and the databases it comprises. It is not enough to have data, data needs to be organized to be useful. Since data is key to decision-making and action in most organizations, the digital platform is mission critical. Data collection and storage in organizations. In a typical business, a production database contains live data that the business uses to produce transactions such as customer requests, inventory management, and sales transactions. Because production databases are in constant use, they should not be used for testing or analysis. Any change to a production database makes the system unavailable for some period of time, which is not desirable when the database is the interface between the company and its customers, suppliers, and other important people outside the company. Instead, when an organization needs to work with a production database, it moves its data to either a development database used for testing or an analytical database used for analysis. Spotlight on ethics. Working with live data. One of the best practices for working with databases is that users do not work directly with the production system. That is, the production database containing the live data that actively run the business. But why? It seems that working directly with the production system would be the most efficient choice. In this case, however, following best practices prevents users from making mistakes that can seriously compromise the business. Don't work with the production system is an ethical issue, part of the code of conduct that all analysts are expected to follow. Watch this video using a case study to discuss this problem to learn more about why this has become a standard in database work. Access is a desktop-based relational database program that can be used to work with a wide variety of data quickly and easily, regardless of its source. Users can request data from the department in charge of the data warehouse, which is a type of data management system that businesses use, then download the dataset to work with to provide actionable information. Let's see how this might look at World Corp. John works as a data analyst for World Corp. The company has a robust data warehouse that stores vast amounts of customer data, sales records, and inventory information. The data warehouse is managed by the Data Management Department, DMD, within World Corp. Other companies may choose to contract out their data management department to a third party. John is tasked with analyzing the sales trends of a particular product category to identify potential areas for improvement. To do so, he needs access to a specific dataset from the data warehouse. John follows the established procedure and sends a formal request to the DMD, specifying the dataset he requires and providing relevant details about his analysis objectives. The request outlines the specific parameters, such as the time frame, region, and product category of interest. Upon receiving the request, the DMD acknowledges John's inquiry and begins processing it. They retrieve the requested dataset from the data warehouse, ensuring that it contains the relevant information needed by John to perform his analysis. After completing the data retrieval process, the DMD notifies John that the dataset is ready for download. John receives an email with a link to access the dataset securely. John clicks on the provided link, which directs him to a secure portal where he can download the dataset. He verifies his credentials and proceeds to download the dataset onto his local machine. With the dataset now available on his computer, John starts working with the data using specialized analysis tools. He cleans the dataset, performs statistical analyses, and generates insightful visualizations to gain a better understanding of the sales trends in the specified product category. After extensive analysis, John identifies certain regions where the product category is underperforming. He also discovers opportunities for strategic marketing campaigns and potential adjustments to the product assortment. John compiles his findings into a comprehensive report, highlighting actionable insights and recommendations based on the analysis of the downloaded dataset. He presents this report to the company's management team, enabling them to make informed decisions to improve the performance of the product category. In this example, the user John requests data from the department in charge of the data warehouse, DMD, downloads the dataset, and uses it to generate actionable information through analysis. Data can come in a variety of formats and configurations. The way in which data is stored can affect how the data can be used, so it is important that a business carefully consider how its data will be stored. There are advantages and disadvantages to each storage medium, but based on the type and volume of data being stored, some storage formats are more suitable than others. Data warehouses. When we discuss data storage, we are typically talking about the data warehouse, a data management system that stores and manages data, especially data related to business intelligence operations and activities. Data warehouses are built for storage, accessibility, and retrieval, as Figure 13.2 illustrates, and often integrate data from a variety of sources within the organization. You may also hear the term data mart, which is a subset of the data warehouse that is optimized for specific workgroups or functions. Typically, data flows into the warehouse on a predetermined schedule, adding to the existing data available for analytical work. Flow diagram displays how sources database, app, flat files, CSV, XML extract, then transform and load to targets, data warehouse, data mart, database. Figure 13.2 data can be transformed in the database through organizing and processing. Credit, modification of extract, transform, load data flow diagram by Bamyers 99/Wikimedia Commons, public domain. A data warehouse is also a type of database, but it differs from the type of database you will use in Access. As an organization's central data repositories, data warehouses hold a lot of information and use a complex structure. Typically, a department or team will include someone who is trained to interact with the data warehouse, using business intelligence tools or other analytics technology. That employee can then use Microsoft products such as an Access database or an Excel spreadsheet for analysis and preparation for management to aid in decision-making. Flat files. Many businesses store their data in flat files, Individual files that have a tabular structure, including single spreadsheets, other tables, and standalone lists of information. Flat files have no set links to other information. In fact, if there are any links, they will be obvious to employees but typically not in documents or parts of the file itself. Flat files tend to look like tables with headers at the top and a row representing each record, as Figure 13.3 shows. Flat file model displays columns, route number, miles, and activity, rows all labeled Record 1. In table I-95, I-495, SR301, route number 12,533 miles, and overlay patching crack seal activity. Figure 13. 3 flat files are mostly static repositories of data, usually represented in tables that workers access directly as needed. Flat files are easiest to use when datasets are small and when the individual using them understands the data well. But even flat files that are quite large, containing thousands or hundreds of thousands of records, can be usable if all records follow a consistent pattern. Flat files are typically created by departments and individual employees in the course of their work, and most organizations have a huge number of these files, which are stored on personal computers and may not be updated or even available beyond the person who created them. In this way, they are a form of dark data, data that is not used or actionable for the organization. Flat file databases are also used in other ways, including the transfer of information from one system to another. For example, suppose a sales organization wants to examine inventory records from a warehouse. In this case, the warehouse may send them a flat file database that follows a uniform pattern, with columns for fields and rows for records. This type of flat file merely stores information. It does not have an index system or any links to other systems, and it is typically in a text format. Common examples of file formats that contain plain text include CSV, comma-separated values, where data items are separated by commas, TXT text, where items are separated by space in the file, or TSV, tab-separated values, where items are separated by tabs. Often businesses must consider the other systems that their database will interact with before deciding on a data format. Plain text is one of the most universally supported formats for data, making it simple to move data between business systems. Relational database management systems. The power in a digital database comes from the ability to connect data from one area to another. A relational database management system, RDBMS, is software that houses, manages, accesses, and retrieves data in its database. The term relational refers to the way that data links together by creating relationships between the tables that hold the data itself. In this way, relational databases can hold much more information that is complex and yet easily accessible. There are many different types of RDBMS in use today. Access is a desktop system that holds information that is typically generated in other, larger database systems running on dedicated database infrastructure servers. For example, a data analyst might use Access at their computer at their desk at headquarters, but will pull the data from the more powerful relational database systems running in WorldCorp's dedicated data center. Still, Access is also an RDBMS, with the power to manage relationships between tables, making it possible to create complex reports. A relational database is a type of database that stores and provides access to data. Relational databases hold a collection of items, with preset relationships between them. Sometimes people use data, database, and relational databases interchangeably, though you may need to pay attention to context to understand if a person is talking about the data, the database, or the system itself. A relational database and RDBMS are designed to give structure to data and to ensure that data is stored and used effectively. Examples of large-scale RDBMS include MySQL, IBM DB2, Oracle DB, and Microsoft SQL Server. Although each of these larger databases support querying and generating reports, in many small to medium-sized businesses, data is often exported and brought into an Access relational database for further refinement, analysis, and reporting, or brought into Microsoft Excel for more complex statistical analysis. Relational databases running in an RDBMS allow us to join or connect tables, perform complex analysis, and run reports efficiently. A join is a function within an RDBMS that sets up the relationship between records in two tables. In a data warehouse environment, relationships or joins that connect tables make it possible to store vast quantities of data and still be able to retrieve them quickly and efficiently. Access as a desktop RDBMS uses the same idea of connecting tables through joins to make data retrieval quick and efficient, and has the added benefit of using a graphical user interface. To work with data in Access, you do not need to know a language such as Java, Python, R, or SQL. Since we often need to analyze information from a larger data store, like the data warehouse, being able to work with relationships makes it possible to efficiently access information from multiple parts of the database. Storing data in an RDBMS. An RDBMS stores data in a database, which is a series of connected tables. The RDBMS provides the software and system structure for the data. The database is the holding area of the data. In practice, the term database is usually used for both of these, but it is important to understand that the data is separate from the program housing it. As a result, you can move data from one software to another program, such as from Access to Outlook or Word for communication distribution. A database can hold a variety of data types in its data tables. A relational database that uses structured data can recognize and process data based on its type. For example, it can understand the difference between text and numbers and process them accordingly. Data types in Access are shown in Table 13. 1. Data type description. Text alphanumeric data in either short or long format. Number numerical data. Date/time date and time. Currency monetary data with 4 decimal places. Autonumber unique value set by Access. Yes/no data stored as yes, no, true, false. OLE object pictures. Graphics or other files that are stored. Hyperlink link to a document, online, local computer. Or network. Attachment full file attachment stored in the database. Calculated mathematical expression or calculation. Lookup wizard field that uses the contents of another table to populate the field. Table 13. 1. Data types in Access. These are some data types typically housed in a relational database. Data manipulation. One of the strengths of a database is that it enables users to manipulate data, changing it in a way that makes the data more useful and actionable. An example of data manipulation is the creation of new fields based on combining and calculating existing fields within the database. WorldCorp often manipulates its data as new products are added to its portfolio or old products are updated with new features. Data manipulation allows users to set up the data in a way that helps them and their audience make sense of it and transform it into business intelligence. Objects and relationships. Objects and relationships are key concepts in a database. Objects are the items that make up a database, including tables, queries, forms, and reports. Relationships link objects together in the database, as Figure 13. 4 illustrates, which in turn improves the performance of the database itself. Customers box with customer ID selected, customer name, customer location inside, and products box with product ID, product price, product stock inside. Connect to sales box with sale ID, customer ID, product ID inside by right-facing arrows. Figure 13. 4 relational databases use tables with defined relationships between them to organize and manage data, while flat file databases typically do not have this level of relational structure. A database object is used to store, reference, or interact with the database. There are 4 main types of objects in an Access database: tables, the structures that hold individual data records; queries, structured data requests; forms, formatted screens for inputting or viewing data; reports, formatted summaries of specific information in the database. A relationship, also known as a join, tells the database that 2 records have a connection. This means we can break up a table into many tables, which in turn keeps screens manageable and speeds up processing. Relationships are created by using a key field, which is a field in a table that serves as a unique identifier for an individual record in a table. For example, in a database about employees, an employee ID number would be a key field and would act as the link between tables that hold employee information, payroll information, and even performance information in a sales department. Instead of trying to hold all this data in one extremely large table, we can have many smaller tables, each specializing in a particular type of data and linked to other tables by key fields, such as primary or foreign keys. Tables. Tables hold the data within a database organized into rows and columns in 2 dimensions. A table consists of columns, each of which is a field, and rows, each of which is a record. The column or field names apply to each record in the table and create the structure the database uses to organize information. A database can include many tables that are joined together by relationships between fields. This structure makes relational databases fast and efficient when retrieving data. Each table typically contains a key field. A primary key field is a unique field in the table, which serves as a unique identifier for the individual record you are looking at. A table can also have a foreign key field, which refers to the primary key field in another table. For example, an invoice number for a sales record is a primary key field. It is unique, but it can also appear as a foreign key field in other tables. In this way, the primary key field prevents duplication in a sales invoice table and also provides a link to the sales invoice list as a foreign key when it appears elsewhere in the database. In Access, primary key fields have an image of a key next to them when viewed in Design View, as shown in Figure 13. 5. A drawing shows a key inside a rectangle with the words primary key printed at the bottom. Figure 13. 5. The primary key is a unique identifier within a database table that ensures each record is distinct and provides a reliable way to access, reference, and link data across tables. Used with permission from Microsoft, key fields make it simple to gather useful information about a single data point from multiple tables. WorldCorp might use a model number as a key field in a database that stores the features, availability, and price of their products. In another database, WorldCorp can use a customer identification number to track various customer metrics such as location, purchase history, and contact information across various tables. Queries. In a large database, it can be difficult or even impossible to find the information you need by simply scrolling through the records. It is even more difficult when a database contains many tables linked by joins. Instead, you can design or build a query, a structured request that allows you to set up criteria instructing the database to return what you are looking for. For example, suppose your boss at WorldCorp asks you to gather sales transactions on a specific date or all transactions for a certain dollar amount. Or you might want to be more specific, asking for all sales of a specific product in a specified time period that exceeded a certain dollar amount. In each case, you can use queries to ask the database to provide the information you need. In many relational databases, structured query language, SQL, is used to create and run queries. SQL is a system of written commands used to manipulate data in a database. It was developed by IBM in the 1970s to allow its engineers to interface with database systems more efficiently. SQL is in Access. However, users can create queries without knowing SQL. Forms. A form is a database object that simplifies the use of information within the database. A form creates a user interface, a way for individuals to interact with the database without directly using the table, which can be slow, overwhelming, and risky because data in the table can be inadvertently changed. A form can be used to input information into a database, e.g., new customer information that customers enter themselves. A form can also be used to retrieve information, e.g., when a customer service representative needs to look up a specific customer record to resolve an issue. Examples of sales forms include customer information, sales invoices, and sales records. Reports. A report is a formatted output of a database, ready for use and action. A report summarizes data in a way that matches the needs of the audience. For example, a product listing on a website or in print is a format ready for presentation to a customer or someone else who needs to see all products at a glance. A listing of sales, summarized by month, is also ready for presentation if the audience needs to know monthly sales figures for a decision or action. Reports are typically one of the final outputs of a database, as they are directly linked to the actionable goal or business intelligence activities of a specific workgroup, team, or project. An example of a sales report may cover sales by product or sales over a time period, such as a month or year. Applications of RDBMS. Databases offer unique functionality that goes beyond the calculations and statistics provided by other programs such as Excel. This is because of the RDBMS functionality. A relational database provides structure for data, includes relationships that connect pieces of data in meaningful ways, and allows controlled access through queries, forms, and reports. Because of this advanced functionality, RDBMSs are used in a variety of use cases across multiple industries. As organizations work to transform themselves to meet the needs of the 21st century, companies are shifting how they view customers, employees, and work in general. Databases play an integral role in this shift. Digital transformation relies on data, and for companies to transform, they need not only good data but actionable data, available when they need it, where they need it. The core of this change is the data management system, and an organization's data landscape is a constantly growing and evolving part of the business plan. Since the digital transformation of a business or organization is about leveraging technology to change the way a business is run, an organization's collection and use of data is an ongoing process, with the focus on people, not technology, and how we enable people to be more innovative, responsive, and successful. Large organizations typically collect data through transactions and sensors, which then store the data. Eventually, data is transferred to a data warehouse, which stores data for historical purposes. From the data warehouse, organizations can bring datasets to a relational database such as Access for analytics and use. Data warehouses and Access are built on relational database models, which provide benefits, including the following. Data accuracy. The use of primary and foreign keys improves accuracy. Easy access to data. Data is held in tables that are easily accessed through queries, improving speed and efficiency. Flexibility. A RDBMS easily scales to include more data and tables as needed by the organization, without affecting the existing structure or the data in the database. Security. Because data is held in separate tables, it is possible to create a variety of user roles and permissions, allowing individuals to access some data without needing full system access. Adaptability. Databases can be easily modified as business requirements change. Because data in an organization is created in production systems and then brought to the analytical system for work, an RDBMS focuses on keeping the data organized and ready for retrieval. The RDBMS also allows the analyst to create database objects that make working with the data more accurate, effective, and efficient. Examples of database use. How do companies apply the information they get from databases? They do so in many ways, most commonly through their marketing and customer service initiatives. For example, WorldCorp's sales and marketing department depends on databases to inform marketing strategy and customer service processes and procedures, and to understand sales trends and future opportunities. Example marketing strategy. Recall that WorldCorp manufactures healthcare products. Its leadership has been looking at their online promotion of allergy medications. They have a variety of advertisements online, served by social media platforms. While they can easily look at the data to see the click-through rate, which is the number of times a consumer clicks an online ad in relation to how many times the ad is shown, and the purchase rate on specific partner sites, they also want to know if they can better understand the customers who are considering purchasing but have not yet done so. Using the data warehouse, you as the WorldCorp employee can request a report of all shopping carts that were populated with a particular medication from an online shopping site partner. Since the data warehouse stores both the WorldCorp information and key information on sales from major partners, you are able to ask for a year's worth of sales data, with customer demographics including location, family structure, and other related purchase information such as, say, other antihistamine and allergy comfort items. You receive the data, import it into Access, analyze it to identify who was likely to add the item to the cart and what they did after placing it in the cart, purchase the item, purchase something else or another action, and prepare this data for the strategy meeting. Example customer service. WorldCorp supplies medication to its vendor partners, including online distributors, both over-the-counter and online pharmacies and physical distributors, as well as healthcare organizations. They are looking to improve the customer experience for their vendors. Now you are the analyst working with the customer service team in the sales and marketing department. You need to understand where vendor needs pain points are to prepare a report for the leadership team. You request a list of all vendor support contacts, which includes the vendor name and contact information, the request itself, including date, time, and method of request, and the resolution. You analyze them to determine the most common types of questions and requests, where these requests originate from, and how they were resolved. You use the dataset to create a report for the leadership team that summarizes and highlights the top issues over the past 18 months. Example sales trends. Next, the sales team at WorldCorp is looking at where to focus their attention for the upcoming year in terms of promoting their medication for obstructive airway diseases such as chronic obstructive pulmonary disease. The team wants to identify areas in the world where their medications may be needed and prepare for the demand. Working with their public health experts, they know that obstructive airway diseases are more common in people who smoke or breathe in secondhand smoke or who live in areas with high pollution. They also learn that people are often over age 40 years when symptoms appear, that asthma increases the chances of developing these diseases, and that they occur more commonly in individuals with certain jobs or who have had a high number of respiratory infections in childhood. You, again as the business analyst, want to identify the geographic areas that are most likely to increase the risk of obstructive airway diseases and look at sales trends in these areas over the past 5 years. You work with the data science department to ensure that the public data that WorldCorp has available and the internal sales data, including the data from the vendor, are available. You then create reports that show specific geographic areas and risks and the sales trends for these areas over the past 5 years. NoSQL databases. In addition to Microsoft Access and other databases that define the relationships between data stored in them, which are the main topics of this chapter, there are other ways that organizations can capture and store data. Non-relational databases. A NoSQL database, NoSQL stands for Not Only SQL, stores data in a different way than the databases we are discussing in this chapter. A NoSQL database, also known as a non-relational database, is a type of database management system that provides a mechanism for storing and retrieving data that is different from traditional relational databases. Unlike relational databases, which store data in structured tables with predefined schemas, NoSQL databases store data in a variety of ways and are designed to handle large volumes of unstructured or semi-structured data. NoSQL databases have gained popularity due to their flexibility, scalability, and high performance. NoSQL databases often store documents and images and manage large amounts of data in their original formats, rather than in tables. This is also known as unstructured data. NoSQL tends to be used when an organization needs to store huge volumes of both structured and unstructured data and also needs the ability to quickly develop and scale data initiatives. Scaling data initiatives is the process of expanding and advancing data-related projects, strategies, and operations to handle larger volumes of data, accommodate increased complexity, and support the growing needs of an organization. It involves implementing measures and techniques to effectively manage, process, and analyze data on a larger scale, often in terms of volume, velocity, and variety. For example, WorldCorp uses a NoSQL database to record logistics for shipping its products. Because the data involved with logistics has unique structure and is greatly varied, a NoSQL database is an ideal candidate for managing this data. Data lakes. You may also hear about data lakes in your organization. A data lake is a centralized repository that allows for the storage and analysis of vast amounts of diverse data in its original, raw, unprocessed format. A data lake can store both structured and unstructured data and make it available for use and analysis as needed. In a data lake, data is collected from various sources, such as databases, applications, sensors, social media feeds, and more, without the need for upfront structuring or transformation. This raw data is stored as is, preserving its original format and granularity. This includes structured data, e.g., relational tables, semi-structured data, e.g., JSON, XML, and unstructured data, e.g., text documents, images, videos. Data lakes offer several advantages, including the ability to store and analyze large volumes of diverse data, support for flexible data exploration and discovery, and the potential to uncover valuable insights and patterns. However, they also present challenges related to data quality, data integration, and ensuring proper governance practices, as the raw, unstructured data may require additional effort for data preparation and cleansing. Although many organizations use NoSQL databases and data lakes, RDBMSs are still the most common type of databases used to power transactional systems, such as managing and tracking customer profiles at WorldCorp. At present, Access does not have a built-in mechanism to directly interface with NoSQL systems or data lakes, although data that comes from a NoSQL database or data lake can be formatted and sent to you for analysis. Learning objectives. By the end of this section, you will be able to demonstrate navigation of the Microsoft Access screen interface, identify the main features of Access, understand how to close Access. The benefit of Microsoft Access is that its design and structure enable it to communicate with other systems that hold data. Unlike larger database systems that run on dedicated servers, Access runs on a regular desktop computer. Because it is a desktop database system, the user can work within the database without connecting to those larger systems. As a Microsoft software package, Access follows many of the conventions of Microsoft Office. This provides a consistent, familiar interface for work and ensures that file transfer is seamless between Microsoft Office software, for example, between Access and Excel. What is Access? Access is a RDBMS that can import and manipulate data from other systems on your desktop computer. While data science professionals work directly with the data warehouse and can create queries using programming languages such as R and Python, individuals who need to analyze data as part of their jobs within a department often find Access to be a user-friendly software package that has the power to access, retrieve, and report data using a Microsoft interface. Access also integrates well with Microsoft Excel, providing even more analytical and reporting power that can inform decision-making. In small businesses and organizations, Access can act as the main data store. However, it is much more likely that you will use data that is collected and stored in other systems and then imported into Access for analysis. The role of Access in an organization. Access is one of the many tools that make up an organization's data landscape, the entirety of data storage and sharing in an organization. An organization may have both production databases and analytical databases. Production databases are systems that handle daily transactions related to an organization's core business functions, such as sales, inventory, human resources, payroll, and purchasing. Because production databases provide value to the organization, companies devote significant resources to ensure they remain online and active. Companies do not work directly with a production system when analyzing a business because this may interfere with regular operations for customer transactions. Instead, companies use a data warehouse or analytical database for building new applications or testing new features. This type of database is entirely separate from the production database, so changes to the analytical database will not modify the production database until the developer is ready to push the changes to the production database after thorough testing. Analytical databases, data warehouses, serve as an organization's single point of truth, spot, in which a primary copy of a data element is stored. Changes made to a data element outside of the data warehouse are not considered final until the primary data element in the data warehouse is also updated. These large databases contain a vast number of records, each of which stores historical information about the organization itself. A data warehouse is not a production system. Rather, it is filled with data from the production system, collected over time and organized in a way that makes retrieval and use easier for business use. We can request information from the data warehouse, which is then exported to a file we can use in our analytical software, such as Access or Excel. The ultimate goal of using data is to make good decisions based on the data and not on emotions. An organization's data landscape can also contain numerous flat files held within teams and workgroups, other systems that run on databases that should be connected to the data warehouse, and even information from vendors and public sources that can inform data. The data landscape may include information scraped from the web, downloaded and processed from public sources, and environmental data. The extent of an organization's data landscape is based on the size and role of the company. Larger companies will often have more complex data landscapes, as will organizations that are undergoing digital transformation and either have or are building a core platform for all business functions. Access and Excel. Access and Excel are both software packages in Microsoft Office. They are complementary. Although they have some functions in common, each package is designed for specific uses. Sometimes, the overlap or commonalities between them can make it difficult to know which is most useful. Both Access and Excel can store large amounts of data, run powerful queries, use analysis tools to manipulate data, and perform complex calculations. However, each software has its own strengths, and choosing the right software will make your work easier, as Table 13. 2 outlines. Use Excel to use Access when you analyze a specific dataset, need to track and record data regularly. Perform complex numerical calculations, need to ensure data integrity. Work with a table for calculations, expect data to be accessed by multiple users. Perform what-if analysis to run scenarios, store data in multiple tables. Create advanced pivot tables and charts, need to connect to other data sources to refresh data either manually or on a schedule. Create visualizations, secure data at the user level. Each user can have different roles and access to specific data. Table 13. 2. Choosing Excel or Access. Excel and Access each have different strengths when handling information. Access and Excel can be used together. It is possible to move data from the data warehouse to Access, and then, as necessary, query and export data from Access to Excel for further analysis and visualization. Transferring data from one program to another is one of the benefits of using a desktop database program. As part of the Microsoft suite of products, both Access and Excel can communicate effectively, so users can also import flat files from Excel and convert them to relational tables. Features of Access. Access is a cost-effective database solution. It runs on a desktop computer and provides an easy-to-use interface that is familiar to users of other Microsoft software. Access interacts well with Excel for deeper analysis, with Word for reporting, and with PowerPoint for presentations. It can work with data from external sources such as a data warehouse or with exported files from the web and other systems. Microsoft Access creates the framework or structure to store small bits of information, data, in a database. Allows users to open tables and scroll through records. Provides an easy-to-use interface for adding, modifying, and retrieving records. Has a process for creating queries to select, combine, and calculate data from multiple tables. Provides user-friendly screens and support for creating queries, forms, and reports that allow access and use of the data held in the database. One difference between Access and other Microsoft 365 software is in its introduction or opening screens. Access loads one database at a time, and all screens focus on the open database. When you first open Access, the screen will be blank, figure 13.6, until you load a database. Once loaded, the screen shows all available commands. Home selected from Access menu, opens to options for blank database, asset tracking, and contacts. More templates with an arrow and search visible. Recent, selected, and pinned tabs at bottom. Figure 13. 6. The home screen will give you the options to create a new blank database, choose from preloaded templates provided by Access, or search for an existing database file. Used with permission from Microsoft. As you move through Access, different commands will become available based on the active objects. For example, you will see different commands when working in tables versus working with queries. The main working area in Access is the center of the screen, with navigation on the left and commands across the top. The opening screen. When Access is open without a database, most commands either do not appear or are unavailable, grayed out. Without a database, the software is inactive. When a database is open on the screen, you will see commands available on the ribbon along the top, figure 13.7, and a navigation area along the left edge of your screen, figure 13. 8. Only one database can be open at a time in Access, and all software is focused on supporting your open database. Create tab options, templates, application parts, tables, table design, SharePoint lists, queries, query wizard, query design, forms, form design, blank form wizard, navigation, more forms inside. Figure 13. 7. The Create tab provides tools and options for creating various database objects such as tables, forms, queries, reports, and macros to design and manage a database system. Used with permission from Microsoft. All Access Objects pane options. Tables, queries, forms, reports, customer address phone book, employee address phone book, invoice, monthly sales report, product category sales, etc. Macros, AutoExec, selected, delete all data, modules. Figure 13. 8. Access has many reports and models already built and modifiable. You might want to consider these before creating one from scratch. Used with permission from Microsoft. As you click through the ribbon, notice that some commands are not available unless you have specific database objects open, and you can move between objects in your database by using the navigation area on the left side of your database screen. Although there are many different database software programs in use, most of them have the same parts. Access as a RDBMS follows the typical database conventions or standards in use in all relational database systems. You can think of Access as a container that holds database objects, which, recall, are items in a relational database. Each object plays a role in managing the database and the data it stores. Because the database is electronic, it can grow to hold many objects and can create links and new uses for each over time. Like many databases, Access databases usually contain tables, forms, reports, and queries. They can also contain macros and modules, which you will learn about in advanced database use. Locating and opening database objects. Once you open the database or the container that holds the object, you will see a navigation area open on the left side of the screen. This area has headings for each type of object that is present in the database, followed by the names of each object you have. To open any object, double-click on its name, and it will open in the main work area on the right side of the screen, Figure 13. 9. To close an object, click on the X next to the name of the object. Access External Data tab selected. Sidebar pane titled All Access Object displays tables options, product category selected. Product Category tab in Document displays Table of Information. Figure 13. 9. Open an object from a database in Access. Used with permission from Microsoft. Tables. Tables hold the data in a database. One database can contain many tables, each of which holds a different record or set of related information or parts of a record. One benefit of a relational database is its ability to split large sets of information about a specific item, person, or idea over multiple tables. This action speeds up processing and gives the database a better organizational structure. As you learned in What is a Database, tables are built with rows and columns. The rows of a table consist of individual records or lines of related data. The columns represent fields or headings referring to information that is likely to be included in all the records. This structure, which characterizes all relational databases, makes it possible to share datasets between different database software packages. An example of table structure is presented in Table 13. 3. ID first name last name middle initial. 1234 Mary Nanas A. 2345 Jose Garcia I. 3456 Andre Williams C. 4567 Lisa Estrich J. 5678 Pat Johnson E. 6789 Stevie Laros Y. Table 13. 3. Table structure. This structure characterizes all relational databases, allowing the sharing of datasets between different database software packages. This small table contains 4 fields: ID, first name, last name, middle initial, and 6 records, which contain the information for each field for 6 different employees. Queries. Queries are a way of asking questions of a dataset. Recall that a query is a structured request for information, allowing you to choose what information appears, the order in which it appears, and how it is organized. Queries can also be used to calculate information based on fields. Typically, when you interact with the database, you will be creating queries to satisfy business requirements. Like other database objects, queries appear in the navigation area of the database. To open a query, double-click it, and it will appear in the work area of your screen. In Access, you can change how you view a query, choosing either Datasheet View, which shows the results of the query in table form, or Design View, which shows the structure of the query and allows you to modify it. You will learn more about these views in querying a database. Reports. A report shows the results of a query, formatted in a business-friendly way. Creating a report allows you to choose the precise information you want to include and the format in which you would like your audience to view it. Since tables and queries typically return results in the form of tables, reports allow you to focus on the message your audience will need for decision-making, not on the data. One advantage of creating reports is that you can set up standard reports that you will need to run frequently, e.g., a report of sales totals, and then open them and view the latest results as often as necessary. Like other objects, reports in Access can be created in a wizard that walks you through the basics, and then you can adjust the report in Design View. Building a useful report can take time and care to ensure it summarizes and displays information in an actionable way that supports the work group's goals. Forms. Recall that a form in a database allows users to work with records in an easy-to-use format. Forms limit the individual's view of the database to what is necessary for a specific task or information request. On most websites, we interact with forms that are built on the basis of queries. They request and present data taken from the underlying table and query structure. Forms are often based on predefined queries that run over and over again, and, as with a search for a product, may prompt the user for a response. Forms appear in the navigation area of the database and can be opened in Layout or Design View, which allows you to modify the form itself, Figure 13. 10, or in Form View Ready for Use, Figure 1311. Inventory Data Sheet tab selected in Design View. Form Header and Detail section include prompts and answer spaces for items. Form Footer follows. Figure 13. 10 Design View allows users to modify and customize the structure and properties of database objects, such as tables, queries, forms, and reports, providing a detailed and precise way to design their database elements. Used with permission from Microsoft. Inventory Data Sheet tab selected in Form View. Clean versions of prompts and blank answer spaces are visible with Previous, Save, and Next buttons at bottom. Figure 13. 11 Form View is the user-friendly interface for interacting with and entering data into a database, presenting records in a user-readable format and allowing data input and editing. Used with permission from Microsoft. Link to learning. Sometimes the best way to learn is to explore on your own. Visit Microsoft's Featured Access Templates page to choose a template and then download, open, and explore it in Access. Closing databases. In Access, only one database can be open at a time. As you work, all on-screen commands will focus on this open database, and you will need to close the database itself to end your working session. When you are ready to close the database, Access will either save objects automatically or prompt you to save objects before closing. In general, Access will automatically save records when you are done with them, i.e., when you leave the row, but will prompt you to save changes to objects, such as tables and queries, so you can decide whether you want to save them. If you want to make sure an object is saved in Access before you close the database, you can use any typical save command shortcut, e.g., File Save, Ctrl+S to request that Access save your changes. Access will prompt you if you need to take any additional steps. When you are done working with your database, click on File, Close to close all objects and exit the Access software. Be sure to close your database every time you are done using it. This will ensure that all objects are closed and that data is correctly written to the records within the database. Learning objectives. By the end of this section, you will be able to explain the uses of queries to explore data in a database. Build and edit a query in Access through the query grid. Establish a relationship between tables with a simple query. WorldCorp collects data constantly in all its departments. The Human Resources Department maintains employee records. The Maintenance Department monitors equipment, repair, and inspection records. And the Accounting Department keeps records on all purchases, to name just a few departments. The data collected in all of these areas can inform decisions, as long as it is accessible and analyzable. The WorldCorp product and sales division constantly updates customer records, processes sales, and maintains inventory levels. It has a data warehouse that powers its transactions, which is continuously working in real time. This information is key to its success, but it cannot work with it directly because that would mean turning the system off. Instead of taking a production system offline for analysis, you will work with a dataset based on last week's work. Working with a dataset can be complicated, and as the datasets get more complex with more records, you will need to be able to query or ask questions using Access. Because Access runs on your computer against a database file, it is quick and responsive and integrates well with other Microsoft programs like Excel for visualization and Word, and PowerPoint for communication. Understanding queries. Queries allow you to ask questions of a database or take an action within a database. To write a query, you need to know the question you want to answer. For example, you might need a listing of all products sold over the past quarter, a list of equipment that needs to be inspected, or a list of products in the company's inventory. Once you establish what you want to know, you can then write a query that will ask the database to share the correct information. A query is really a question written in computer syntax. The query collects data that meets your specifications by running against the table S in your database. A query can be simple, for example, returning all values in a field in the table, such as product ID number. A query can also be complex, limiting the dataset and results to precisely what you are looking for. Expressions that a database management system uses to limit the results of a query based on matching field values are called criteria. Adding criteria enables you to control what data you see so that you can identify the records you need and omit the ones that do not meet your needs. In turn, this makes it easier to answer questions and visualize the data you need. Before you create a query in Access, you should have a strong understanding of what you want from your dataset. For example, WorldCorp could be interested in discovering how their latest product has been selling based on data in their transactional database. To accomplish this, you might need to look for sales that match certain criteria, such as sales for a specific product identification number. Knowing this in advance and putting it in writing will help you craft useful queries. When planning a query, you will want to identify the following: the fields you want, the value S you expect in each field, any calculations or changes you want from the data, how you want the data displayed, e.g., in order by date. Although the steps are the same in building both simple and complex queries, the planning process becomes more important the more complex your queries are. Queries can be designed for a single use or built for ongoing work. Ad hoc queries typically answer a specific question and are needed only at the moment you create them. Once you are done with an ad hoc query, you will not use it again, so it does not need to be stored or saved. Other queries, called predefined queries, are set up and saved. Predefined queries are used to automate data management tasks that meet specific organizational needs. An example of a predefined query is a sales report or top-selling product report that you frequently run without change or with only minor changes. In this case, you will want to save the query to make your work easier. You might even want to set up a screen with all of your predefined queries. The purpose of queries in databases. Queries are an essential part of making a database accessible. Imagine trying to make sense of hundreds, thousands, or even more records without a tool to help you. It is simply not possible. The more complex your dataset, the more important it is to use queries and reports to retrieve data. Most databases have too many records to work with unless you have well-written queries. A well-written query is specific, organized, and comprehensive, meaning that it contains everything you need. Spotlight on ethics, protecting the privacy of data. The Target data breach in 2013 was a significant security incident, resulting in the theft of 40 million credit and debit records and 70 million customer records. The breach demonstrated that such incidents can severely undermine customer trust and confidence in data security. Customers concerned about the potential leakage of their data became wary of Target, leading to decreased sales reputational damage. The breach also highlighted the need for companies to ensure the security of their vendors. Target's compromise, for example, originated from a third-party vendor. Cybersecurity is a weakest link proposition. Organizations must consider the security of all parties involved in their data ecosystem. Although Target's handling of the breach included prompt notification to customers, it was clear that additional precautions could have been taken that would have made the attack more challenging for cybercriminals. The incident highlights the need for proactive security measures and robust disaster preparedness plans. Furthermore, the breach had financial implications that went beyond the settlement costs. Target experienced reduced earnings and a decline in customer patronage. The ultimate cost of the breach was estimated to be well over $200 million. The Target data breach serves as a reminder for organizations to prioritize data security, protect customer information, engage in proactive defenses, and have strategies in place to restore customer trust if a breach occurs. See this coverage of the Target data breach and think about how your data may be stored and used by companies and websites, and also about how you, as a professional, need to manage data to protect it and the people who have shared it with you and your company. You are most likely to use queries to retrieve a specific record or set of records, but queries have other functions as well. For example, they can summarize data and perform calculations. You can even set up queries that show you the most current data in the database each time you refresh your records. Designing queries. Before building a query, you need to take some time to think through how the query will work and what it will accomplish. Start with a question such as one of the following examples. What does inventory look like right now? What sales were made last week? What were the top products sold based on volume last quarter? These questions demonstrate in detail how to structure the query. Once we have the question in mind, we can then consider other items that inform our query design. What data is available, where it is located, how it may need to be processed, e.g., sorted, filtered, or calculated to get to the answer, and how the output should be organized, e.g., sorted by date. This design or model tells you how to create the query in your software. Once you have created the query in Access, you will need to test it by running it a few times to make sure it returns the values you are looking for. You will likely revise your queries as you test them. Remember that the more complex a query is, the more revision and testing you will need to do. A query based on your question or need for information contains specific components. In Access, these are as follows: the name of the query if you will be saving it, which appears at the top of the query screen. The field in which your data is stored. The table in which the field is located. Sort, which determines the column that will be used to sort the query, e.g. in numerical order by product ID. Criteria, text that can be used to limit the results of a query, or which allows you to create more complex statements. When you create a query in Access through the Query Wizard, figure 13. 12, these areas will be filled in by the wizard. If you need to modify a query or want to create one without using the wizard, you will use the query grid to set up the query. You learn more about this later in the section on editing queries with the QBE grid and in the chapter on advanced database use. Simple Query Wizard asks, which fields do you want in your query? Selections include tables, queries, table, customers, available fields, email address, selected fields, first name, arrow buttons visible between fields panes. Figure 13. 12. The Query Wizard guides users through the process of creating database queries step by step. It provides a graphical interface to help users select tables, fields, criteria, and sort options, making it easier to generate complex queries without writing code manually. Used with permission from Microsoft. Using these areas of the query allows you to accomplish multiple tasks, including choosing the data you want to include, omitting data that is not of interest to you, sorting data, and even combining data from multiple tables. Running a simple query. A simple query is one that finds and displays information. Very simple queries may show all the data in the database in columns or all the information in one specific field or column. Once a query has been created and saved, you can run the query whenever it is needed to return the updated results. Each saved query has a name associated with it, and typically these names follow a specific pattern that helps you to differentiate between them. For example, a version of a customer list sorted by last name and the same list sorted by state would be named QRY customer last name state. In the Access database with queries, you will see a list of saved queries in the navigation section of your database. For example, in the database shown in Figure 1313, you can see 4 queries under the queries heading: Product Category List, Product List with Client Information, Products Active, and Products All. These simple queries are already created. To run them, simply double-click on the name of the query you want. External Data tab selected. All Access Objects sidebar lists options under Queries. Product List with Client Information selected. Figure 13. Use saved queries to prevent repetitive query design in Access. Here, the saved query product list with client information is selected. Used with permission from Microsoft. Once you double-click on a query name, it will open and show you the results table. The query will generate updated results every time it is opened, allowing users to use a simple query over and over, even as data is refreshed in your database. When queries or any database objects are open, you will see the name of the object on a tab above your work area. To close a query, click on the X to the right of the object's name. Switching views. Access can switch between the design view of the query and the results of the query. For queries, you will frequently change views to move back and forth between the underlying query structure and the results of running the query. When you look at the structure in Layout view, you can modify how the query works. When you go to SQL view, you are also able to modify the query structure. See Figure 13.14. Query Design tab selected. View button selected, and options include Datasheet view, SQL view selected, Design view. Products All in Queries selected and opens in Windows. Table along bottom reflects query information. Figure 13.14. Viewing a query in SQL view allows you to see and edit the underlying SQL code that defines the query's structure and criteria. Used with permission from Microsoft. To change views, first click on the View command on the ribbon, and then choose the view you would like to see. You can choose from 3 views. Datasheet view shows you the results of the query in table form. SQL view shows the query in structured query language form. Design view shows the query in the form of a QBA query by example grid. Using these views, you can see your query in multiple ways, first visualizing the query and then seeing the results quickly. Query walkthrough. In today's fast-paced business landscape, staying ahead of the competition requires a deep understanding of your products and their performance. WorldCorp's state-of-the-art sales and marketing database is designed to maximize their sales potential. At the core of this powerful database lies the ability to perform queries that deliver invaluable insights. A query in WorldCorp's sales and marketing database returns a list of products, including the product ID code, product category code, and notes, if any are present. Notice that there is only one table called the product list and that all 3 fields are used in the query. First, Figure 13.15 shows the query in Design view. Note that the list is sorted in ascending order based on the product ID. The result of the query is shown in Figure 13.16. Select button in Query Design tab selected. All Access sidebar selects Products All from Queries. Product List query open in Window and Table with reflected information along bottom. Figure 13.15. Using a query creates a list of all products found in a database. Used with permission from Microsoft. All Access sidebar selects Products All from Queries. Products All tab displays columns of information with product ID, product category ID, and status. Figure 13.16. The result of the query will return everything in the database that fits the criteria you included in your query fields. Used with permission from Microsoft. Now let's look at a query that uses more than one table. In this example, the query returns a list of products with information about wholesalers who have showed interest in those products. 3 tables are used: product list, list of products that WorldCorp offers; wholesaler list, list of wholesalers that WorldCorp works with; wholesaler interest list, table that includes product ID from product list and wholesaler ID from wholesaler list. See that the tables are joined by the fields product ID and wholesaler ID. If you used only the wholesaler interest list table, you would not be able to display the product category or the wholesaler name, information needed to make the results of the query useful for the sales and marketing team. If you look at the grid in Figure 13.17, you will also see that the table uses sorting and an expression, a combination of 2 fields displayed together. The results are shown in Figure 13.18. All Access sidebar selects Products All from Queries. Products with Wholesaler Info tab in window displays connected queries for Product List, Wholesaler Interest List, Wholesaler List. Table at bottom reflects queries. Figure 13.17. A query across several tables can create a sorted list of products from the database by combining data from more than one table. Used with permission from Microsoft. Product with Wholesaler Info is selected in Queries of the All Access sidebar. Product with Wholesaler Info tab open in window with columns of information for Product List. Product List, P Expert 1 and Wholesaler List. Wholesaler Mailing Address All. Figure 13.18. The results will display only the columns that you chose to show in your query. Used with permission from Microsoft. Notice that this query combines several different techniques, including the use of multiple tables, sorting, criteria, and even an expression that combines fields in the query, in this case, the wholesaler ID and name. This is just a small demonstration of the power of queries, real-world application. Using data to make informed decisions. Netflix collects and analyzes vast amounts of user data, including viewing history, ratings, and preferences, to drive their content strategy and personalized recommendations. By analyzing this data, Netflix can determine which TV shows and movies are popular among different segments of their user base, make data-driven decisions on content acquisition and production, and provide personalized recommendations that enhance the user experience. This data-driven approach has contributed to Netflix's success in delivering highly relevant and engaging content to their subscribers. Netflix also uses data to make informed decisions in other aspects of its business, including the following. Content acquisition and production. Netflix analyzes viewership data, user preferences, and market trends to help it make informed decisions about acquiring rights to existing content or investing in original content production. Audience segmentation and targeting. Netflix leverages user data to segment its audience based on viewing habits, preferences, and demographics. Pricing and packaging strategies. Netflix analyzes data on user subscriptions, engagement levels, and pricing experiments to assess the impact of different pricing and packaging strategies. User experience and interface design. Netflix utilizes data on user interactions, browsing behavior, and feedback to continuously improve its user interface design and user experience. Netflix runs experiments, conducts A/B tests, and gathers user feedback to refine features, layout, and content presentation, ensuring an intuitive and engaging viewing experience. Customer service and support. Data analysis helps Netflix identify patterns and trends in customer support interactions, enabling it to improve response times, identify common issues, and enhance customer satisfaction. Netflix can also proactively address potential issues by analyzing data on streaming quality, buffering, and device compatibility. Using this data-driven approach, Netflix can make informed decisions that drive customer acquisition, retention, and overall business growth, allowing it to stay ahead of the competition, continuously improve service, and deliver a highly personalized and satisfying entertainment experience to millions of subscribers worldwide. Saving and closing the query. The first time you create a query, you need to give it a name. After that, if you modify the query, you will need to save it, and doing so will update the copy you have. To save the query, you can click on the Save icon on the Quick Access toolbar or use Ctrl+S on the keyboard. Access will also prompt you to save when you close a query that you modified. If you do not plan on using a query again, or if it is extremely straightforward, you may not want to save it. But if you are likely to reuse the query, you will want to give it a descriptive name. It makes sense to create a naming schema that you can continue. For example, if you are querying for a specific project team, you may start with the team name like Product Team to help you identify the query later on. Building and creating queries. WorldCorp needs to quickly gather data related to sales records of their new healthcare product in the market of Southeast Asia. Although you could design a query to gather relevant information from scratch, Access has a convenient wizard that can help you design a suitable query. Wizards are small programs that run within Access to help you set up the objects in your database. A wizard will prompt you to add the information you need. For example, the query wizard will ask questions that will help you decide what table or tables you want to work with, the fields you will use, and how you will display the output. Once you have created a query with the wizard, you can modify it however you like. To access the query wizard in Access, click on the Create menu and locate the command for Query Wizard. Choose the type of query you want to build. In this case, we choose the simple Query Wizard, as you can see in Figure 1319, which selects and displays specific records. This is the most commonly used query. New Query pane displays options for picking fields for query. Simple Query Wizard selected, Crosstab Query Wizard, Find Duplicates Query Wizard, Find Unmatched Query Wizard. Figure 1319. The Query Wizard can be used to create simple queries, crosstab queries, or queries to find duplicate or unmatched records. Used with permission from Microsoft. Use the button to choose the table or queries and the fields you want to use in the query. You can add from different tables or queries by changing the Table Queries drop-down menu to choose a different object to work with. When you are finished, click Next to move to the next screen, see Figure 1320. Simple Query Wizard pane asks, which fields do you want in your query? Selections include table queries, table, product list, available fields, blank, selected fields, status selected. Arrows visible between field panes. Figure 1320. The Query Wizard allows you to select individual fields you want to include in your final query, used with permission from Microsoft. Once you have set up your query, you can name it on the last screen and choose whether you would like to see the results of the query, view information, or modify the design of the query, modify design. Then click Finish. Figure 1321 to build the query. Simple Query Wizard pane displays product list query for query name question. Open the query to view information selected for do you want to open the query or modify the query's name. Figure 1321. The Query Wizard allows you to title your query before finishing it, used with permission from Microsoft. Editing queries with the QBE grid. Once a query is built, you can edit it using the QBE grid, which gives you the ability to look at a query and rearrange, modify, and add to it, as well as the ability to run the query and see the results. To open a query in the QBE grid, right-click the query in the navigation area of the screen, or to open the query, click on the View command and choose Design View as Figure 1322 shows. View button selected and opens to options, Datasheet View, SQL View, Design View. Product Sol is selected from Queries. Tab for Product Sol opens at right, listing information in 3 columns. Product ID, Product Category, Status, Figure 1322. The View command gives you a few different options for viewing a query, used with permission from Microsoft. The QBE grid. Figure 1323 allows you to interact with a query visually. It places the elements of the query on screen in order from left to right and gives you the ability to modify the format of the query. You can do the following using the QBE grid: view, add, or change the tables used in the query. Add or reorder fields. Sort values returned by the field. Choose whether a field is shown in the query, e.g. You may want to sort or use a field but not have it appear in the results. Add criteria to limit the records returned by the query. Student Attendance Count tab displays queries. Students includes ID, last name, first name, etc., and student attendance ex-day. Highlighted, other options include student name, file as, etc. Table at bottom reflects queries. Figure 1323. Use the QBE grid to interact with or modify a query, used with permission from Microsoft. Building a query with the QBE grid. Although the Query Wizard is a useful tool and a good way to quickly start a query, using the QBE grid gives you more options for building complex queries. The QBE grid consists of a table that makes commands available. In setting up the query, follow these steps: add tables, choose fields 1 per column header, choose the sorting criteria, run the criteria to see results. Return to Layout View to continue working. To set a sort order which will control the order of records displayed in the query, follow these steps: view the query in Design View, locate the column you want to sort. Click on the down arrow in the sort row and choose the sort order: ascending, descending, or not sorted. By default, the column is not sorted. You can also set criteria here to control which records are displayed. Criteria are commands that are written using symbols together with a text string that tells Access what you want the query to do. A criterion statement has two parts: the criterion operator and descriptive text. For example, in the criterion statement, equals 100, the equals sign serves as the operator and 100 is the descriptor. There are several different criteria you can use within your queries. Some of the operations criteria are displayed in Table 13. 4. Criterion result equals returns values that are equal. Equals 99 will return all values that are 99. Returns values that are greater than 99 will return all values greater than 99. Returns values that are less than 99 will return all values less than 99. Is null returns records with empty cells. Note: null signifies empty, not zero. Return records that are an exact match to whatever is between. Like returns records that contain the value between. Like GP will return all values containing GP. Not returns values that do not match the criteria. Not 100 will return all values that are not 100. Table 13. 4. Display criteria using criterion statements adds power to a query. They allow you to build complex queries that organize data in interesting and useful ways. Databases can hold hundreds, thousands, and even hundreds of thousands of records. One way to limit the results to what is relevant to your project or to the decision you need to make is to use criteria to limit the data that a query returns. Limiting the results makes it easier for you to work with the data and helps ensure that your decisions are both accurate and effective. Setting criteria can help you select specific items in an Access database by showing only items that match the criteria you have set in creating the query. Individual criteria can be used in expressions or statements that specify values to select or omit. Using tables in queries. The query grid will open with a blank gray area, a blank table across the bottom of your screen, and a window in which you can add tables. To add a table to the screen to work with it, double-click the table name or click and drag it into the gray area, figure 1324. You will likely want to work with more than one table at a time, as one of the reasons we use relational databases is to be able to split our data into multiple tables and then combine them as needed, giving us enhanced performance and flexibility. To work with multiple tables, drag them onto the screen or double-click them. If you have a query open in the QBE grid, you can add tables to the screen by right-clicking anywhere in the table area and choosing the Show Table command. Select button Query Design tab selected. Product Sol selected from Queries. Window displays Product List Query. Add Tables sidebar displays Queries tab selected. Product Sol options. SQL View, Datasheet View, Show Table, Parameters, etc. Figure 13. 24. Adding an additional table to the query grid view allows you to create queries that involve multiple tables, enabling you to retrieve and analyze data from multiple sources simultaneously. Used with permission from Microsoft. Joining tables. Splitting data into tables in a relational database like Access enhances database performance, which is a key issue in working with very large datasets. It also increases flexibility by allowing us to chunk or separate our data into smaller sets which are easier to work with. Splitting up the data also enables us to avoid creating many null, empty fields. Imagine using a single spreadsheet to manage all your information. It would not be useful as it would have too many fields, and many of those fields would be blank. When using a relational database to separate data into smaller ID-focused tables, e.g., a table including only salespersons, another for clients, you need to join these tables based on key fields. In this example, you would likely create a primary key, sales rep ID, on the sales rep table, and then include this same field as a foreign key on the client table. You can then create queries that will join these tables by making sure that Access understands the connection between the fields. In fact, the ability to create and define relationships between tables is one of the most important functions of a relational database. If you consider a database a set of data tables with relationships between them, Access needs to be able to connect related fields between one table and another. It does so by means of the connection or relationship known as a join. A primary key or unique key is a field that uniquely identifies a record. As with an ID number, no two records can have the same primary key. A foreign key field is a primary key field that appears in another table. We can join foreign keys to primary keys to create a relationship between the two fields. Recall that a join refers to the relationship between two fields in different tables. Access will create a relationship or join when it sees a primary key field in one table and the same primary key used in another. This is because Access understands that these fields have a relationship. Joins appear between two fields in two or more tables in the query design screen. They are shown as lines connecting the fields, which represent the relationship between the two tables as a one-to-one, one-to-many, or many-to-many join. Access will create a join automatically when it recognizes the same field in two tables. At times, however, Access will not recognize the relationship, or you may want to relate two fields for the purpose of a specific query. In these instances, when we realize that two fields are related but that Access does not automatically understand this, we can also create joins manually. For example, this happens when different field names apply to the same field. A person may realize that customer number and customer ID are the same, but Access likely would not recognize this. In this case, it is our job to add the relationship, letting Access know that these fields should be joined when we perform a query, as Figure 13. 25 and Figure 13. 26 show product lists selected from tables in All Access sidebar. Products All tab displays queries for product list, product ID, product category, status, and product category ID description. Table below reflects queries. Figure 13. 25 using joins in a query allows you to establish connections between fields in different database tables, enabling you to retrieve and display related data by specifying how the tables are linked based on shared values or keys. Used with permission from Microsoft. Join properties pane displays left table name product list, right table name product category, left column name product ID, right column name product category ID. Only include rows where the joined fields from both tables are equal selected. Figure 13. 26. The Join Properties dialog box enables users to specify the type and criteria for joining tables in a database query, defining how records from multiple tables are related and included in the query results. Used with permission from Microsoft. Types of joins. There are two main types of joins, inner and outer. The type of join controls what data will display when the query runs. In an inner join, Access looks at the common fields and data between the two tables and only displays the matches, omitting any records from either table that do not match. The inner join is the most common type of join and is the default type for Access. In an outer join, Access looks at the common fields and displays the related matched data plus the rest of the records from a single specified table. You can use the Join Properties box to choose which table will have all its records displayed. As an example of an inner join, the Sales and Marketing database has a table with client information and a table with sales invoices. Both tables include the field cliented. These tables are related using the default join type, the inner join. Suppose the team at WorldCorp needs to see a list of all products with the clients that have purchased them so they can share new sales information appropriately. The tables in Figure 13. 27 include the fields Client Info and Sales Invoices. Client Info table ID, Client Name, etc. And Sales Invoices table, Sales Invoice ID, Sales Invoice Date, Client ID, Product ID, etc., with a line connecting Client ID between both tables. Figure 13. 27 Access uses lines between tables to denote that a relationship exists between them. Used with permission from Microsoft. After looking at what the team actually needs for the process, you decide to add the fields from Client Info, including Client ID, Client Name, and Client Mailing Address all, and to use two Sales Invoices table fields, Client ID and Product ID, to narrow the results to just the clients who have purchased specific products. After creating a new query and adding both tables to the grid, you realize that Access did not automatically create the join. You drag Client ID from the client table to the matching Client ID in the Sales Invoice table. This creates an inner join which will return only the details for the records that match. You then add the fields for the query into the query grid. Add the Product ID field first because it should appear first on the screen. Then add the client ID field followed by client name and client mailing address all. Using these fields as figure 13.28 shows, you created a query that returns a list of each product, followed by the clients that purchased it. By adding client ID, client name, and client mailing address all, the team can send the correct mailings to the customers that have purchased these specific products in the past. Product category selected from tables in all access sidebar. Query 2 tab displays queries for client info and sales invoices. Line between the tables connects client ID. Table below highlights columns with client ID, client name, and client mailing address all. Figure 13.28 a query can use joins to return lists with data from multiple tables. Used with permission from Microsoft. Creating joins. To create a join in Access, you need to have both tables open on the query design screen. With the tables open, click on the field you want to join in one table and drag it to the matching field on the other table. Access will usually create an inner join, displaying only the records that match on both tables. If you want to display the data differently, you can double-click the join line and change the type of join. To change a join, double-click on the join itself in the query grid. The Join Properties box, figure 13.29, will open. In the box, you can change the tables or columns of the join and can also change the type of join relationship. Sometimes it is helpful to modify the join on a dataset to see the results. The Join Properties box is helpful because it gives you a quick reminder of the results you can expect from the join, using the names of your tables. Join Properties pane displays: left table name product list, right table name product category, left column name product ID, right column name product category. Only include rows where the joined fields from both tables are equal selected. Figure 13.29 you can change a join in the Join Properties box. Used with permission from Microsoft. If you decide you do not want or need a join for any reason, you can click on the join line in the query layout view and click Del on your keyboard. The join will be removed. Learning objectives. By the end of this section, you will be able to examine existing records in a database, construct new records to add to a database, update existing records in a database, demonstrate the process to delete records from a database. Most of the time, when employees maintain and work with a database, they access data that has been provided to them from another data storage area, such as the company's data warehouse. The tasks in the analysis are to import the data, review the data to ensure that it is brought into the database correctly, and then use the data. Sometimes, however, users need to complete other tasks to ensure that the database processes the data correctly. Link to learning. Data integrity is a cornerstone of the digital organization. Without data that can be trusted, companies cannot transform themselves to be successful in the digital world. Transformation comes with two data-related problems: how companies store and access data and the quality of that data. For an overview of these issues, read this article on data integrity in business and think about the ethical requirements for the data professional and organizational leadership, and how they need to balance the quality, security, and accessibility of data within the organization. Reviewing records in a database. It is possible to view records in database tables, but be sure to not change the records. In a table, records are shown on a datasheet, with each column equaling a field name, a value that all records have, and each row representing an individual record. On the datasheet, there are commands that let you move between records. You can also use the scroll bars to look at different parts of the table. Although using the datasheet to view records can be useful in limited situations, databases typically hold a great deal of data. So in general, querying the table will be a much more efficient way of finding the records you need. Figure 13.30. Table displays columns for product ID number letter combinations, product category ID N05B listed in the entire column, status with active, on hold, and retired listed as options, and click to add all blank cells. Figure 13.30 reviewing records in a datasheet provides a broad overview of the data, while querying allows you to filter and retrieve specific information that answers particular questions or meets specific criteria. Queries are used to extract precise and targeted data from a database, whereas a datasheet presents a more comprehensive view of the data. Used with permission from Microsoft. Real-world application. Data flow processes. Date flow chart shows data collected by production systems. Production databases, OLTP, production systems copy data to data warehouse, data storage, OLAP, data copied sent to work groups in Microsoft Access Excel, Microsoft Access. Figure 13. 31 data flows through an organization's information systems from collection to analysis. Data moves across the data landscape from transactional production databases, including sales, customer service, human resources, and other systems, to storage databases such as the data warehouse, which can hold historical information, online transaction processing, OLTP. Once housed in a data store, datasets can be made available to databases like Access and spreadsheets like Excel for local use and analysis, online analytical processing, OLAP. Why would it be important to keep in mind how and when data was collected from a production system when performing analysis on that data in Access? If you need to look at records in Datasheet view, there are commands at the bottom of the screen that will help you move between them. When a datasheet view is open, these commands appear automatically in Access on the bottom left side of the screen. The record navigation buttons open any time that records are shown. As you work in the database, you will see these buttons in Datasheet view and in certain form views. The command buttons include jumping to the first or last record in the series, navigating one record ahead or back, and adding a new record, as you can see in Figure 13. 32. You can also add a filter or use the search feature to find a specific field value. Lines with arrows pointing to buttons left-right labeled move to first-last record. Arrows pointing left-right labeled move one record forward-back. Arrow pointing right with sun icon labeled add a new record. Figure 13. 32. Using the record navigation buttons to progress through a datasheet can save you a lot of time. Used with permission from Microsoft. Constructing new records. Databases are historical in that they record past details about an organization, but they also need to be updated as time goes on. There are a variety of ways to update a database, including both manual and automated updates. Most of the time, when you use Access, you will import a dataset or file from another system, such as the organization's data warehouse. Adding a record manually. If you need to add a record into a database, you can either add the record to the table manually or import it from another database. To add a record manually, open the table in Datasheet view. On the Home tab, click the command New in the Records group. Fill in the information using Tab or the left and right arrow keys to move through the record. Once you are done, use Tab or the up and down arrows to move to the next record, or press Shift plus Enter, or any version of save that saves a record. Importing a record. Creating files that can be imported to other systems is a hallmark of a digital organization. When working with Access, we are likely to import files from other, larger systems. Data is collected in business units across an organization, and using that data is key to an effective business. Business units routinely transfer files between systems, which in turn lets units analyze and create actionable information. Most systems can create comma-delimited CSV files, which use commas as delimiters or breakpoints to tell Access or any other program where data should be separated. CSV files can be read into most Microsoft products and other popular software packages. There are also other formats designed for importing and exporting files, which use another type of formatting to delimit or separate data. Access can import a variety of file types, including Excel, CSV, and XML, as well as files specific to databases and other systems or software products. Even so, CSV is one of the most common formats for data importing. Figure 13. 33. Before importing a file, be familiar with the file and its contents. To make the import process easier, you may want to rename fields so that they match in the file and the database. Once your file is ready, you will likely want to import it to a new table so you can catch and correct any errors without corrupting the data in your other data tables. Depending on the specific type of work you are doing, you can either set up a table ahead of time or import the data into a new table. Notepad displays tabs: File, Edit, Format, View, Help. First line reads: Product ID, widget color, sales, units sold, order date, ship date, phone. Lines of information follow for the rest of the page. Example of one line. 1 red 1004042022070 Figure 13. 33. A CSV, comma-separated values file is a plaintext file format commonly used for storing tabular data such as spreadsheets or databases. Used with permission from Microsoft. Note: Access has the ability to import data directly into existing tables manually through the import command and by connecting automatically with a database or system. Follow these steps in importing a file. With your database open, select the External Data tab in Access. Choose the New Data Source button. Choose the file type you want to work with, for example, text. A dialog box will open. Select the file you want to import. Choose the import type that fits best with your project. If you are concerned about an import, try importing the data into a new table to be sure you have all of the fields and parameters set correctly. Click on OK. The import screen will open. See Figure 13. 34. Import text wizard pane displays delimited characters such as comma or tabs separate each field selected. Sample data from file displays in pane first row. Datum M01 OB M01I N02BA N02B N05B N05C R03 R06. Other rows include 1520141411 6721 3185 95,410,327 Figure 13. 34. Importing a file using the Import Text wizard allows the user to select the correct format for their file. Used with permission from Microsoft. The Import Wizard, which is a part of the import process, will open and ask you to choose how your text file is structured. Hint: most text files are delimited, and CSV files use commas as the delimiting or separating character. Once you choose whether the file is delimited or fixed width, broken up based on a certain number of characters, click Next to continue. On the next screen, set your delimiter comma for a CSV file and click the first row that contains field names, assuming your first row is titles or labels. Then preview the data, and when you are sure it is correct, click Next to move to the next screen. See Figure 13. 35. Import text wizard pane displays comma as delimiter that separates fields. First row contains field names is selected. Columns include datum, M01 OB, M01I, N02BA, N02BE, N05B, N05C, R03, R06. Other information follows. Figure 13. 35. For files that use a delimiter, the Import Text wizard requires that the user define which delimiting character is used. Used with permission from Microsoft. In the screen that appears, you can change field names and data types if necessary. Figure 13. 36. Once you are ready, click Next to continue. Import Text wizard displays field options. Field name datum, data type date with time, indexed no. Do not import field skip, not selected. Columns listed in pane datum, M01 OB, M01I, etc. Figure 13. 36. The Import Text wizard allows you to specify various field properties, such as name and data type, before importing the file to Access. Used with permission from Microsoft. The Import Wizard will ask if you would like to set a primary key or have Access set it for you. Make your choice, as seen in Figure 13. 37 and click Next to continue. Import Text Wizard selects Let Access add primary key. ID column visible before other columns. Datum, M01 OB, M01I, N02BA, N02BE, N05B, N05C, R03, and R06. Figure 13. 37. You should select a primary key for any imported tables. This primary key can serve as a unique identifier for each record in your database. Used with permission from Microsoft. The final Import Wizard screen will allow you to name your new table. Be sure to use a descriptive name that distinguishes it from the tables you already have in the database. When you are done, click Finish to view your new table. If your table has errors, e.g., if data cannot be imported because of mismatches in the field type, a new table containing the errors will appear in your list, as Figure 13. 38 shows. If you find any errors, you may want to delete your imported tables and walk through these steps again. All access sidebar visible with staff 2014 import errors selected in tables. File open at right lists columns of information detailing errors. Figure 13:38 A table with errors will still be imported, but the errors will be identified in a new table with the phrase import errors in the title. Used with permission from Microsoft. Link to learning. Data management is a bigger concern than just tables and fields. Data professionals at all levels need to understand the data landscape and how organizations can manage it. This article on data lineage provides an overview of some of the challenges and considerations in data management. Editing or deleting an existing record. Once you locate the record you want to update, you can edit it. To edit a record, open the table in Datasheet View or Form View. Click on the field you would like to edit. Place your cursor where you want the information to appear. Enter your text. Use Tab to move across your record. As you work, Access will save your changes whenever you move your cursor from one field to another. If you want to save the record manually to be sure your data is saved, you can either click the Home tab, then click Save in the Records group, or press Shift plus Enter on the keyboard. When you are updating a record, you may see symbols appear that share the status of that record, as Figure 13:39 shows. As you manually edit records, pay attention to these data entry symbols. Gold square. Record being edited saved. Pencil, record being edited not saved. Asterisk, new record ready for information. Key triangle, primary key field. Crossed out circle, locked record cannot be edited. Figure 13:39. These are some of the common icons you will use in data entry, used with permission from Microsoft. Learning objectives. By the end of this section, you will be able to understand why reports are useful. Create and edit a report using the report wizard. Customize a report by adding images and text. Databases are useful only if they enable us to transform data into information that will be ready for use when it is needed. Although queries are helpful in extracting the data that we need and even transforming it into actionable information, most decision makers will need more refinement, formatting, and preparation before the data is ready for use. Recall that a report is a formatted display of information designed for a specific use case or project. Reports do more than summarize information, they also create the foundation for making sound decisions. When we combine queries with formatting, we create reports that we can use in our work, using reports in a database. Reports are a cornerstone for business decisions. We can generate reports within a database for a specific request, and we can also set up reports to provide summaries and information that we will need on an ongoing basis. Access enables us to set up reports, e.g., a financial, sales, or summary report that we can then access as necessary for decision-making. Companies routinely run reports on key performance indicators, KPIs that show an organization's effectiveness, efficiency, quality, economics, project performance, resource use, and personnel and workforce performance. Companies also routinely look at revenue, profit, and customer and employee satisfaction. Because tables filled with data do not adequately describe KPIs, businesses rely on reports as part of their evidence-based decision-making. Tables are extremely efficient ways of storing data, and using a relational database with connections across tables is an effective way of building information storage. Unfortunately, however, tables do not display information in ways that people easily understand. We can manage this by creating reports, formatted, attractive displays of information. Reports use combinations of labels, values, and even graphics to present the results of a query in a way that supports action. Once designed, a report can easily be reused or copied and revised. Like other objects such as queries and forms, reports will show the most up-to-date information each time the database changes. Among the many reasons to generate reports are the need to create summary reports, to save snapshots of data, and to provide detail about specific customers or products. Consider this example. Anna, an analyst in the sales and marketing group at WorldCorp, has been asked to get data ready for a meeting with sales representatives. The meeting will focus on products that are on hold, and the representatives will need to identify wholesale companies that may be interested in these products. Anna begins by determining what the sales representatives will need for the meeting and the level of detail they will want to have available for decision making. She then looks at the available data and decides how to create the report. Anna's final report includes two sets of information: the list of on-hold products and the list of wholesalers who have shown an interest in those products. Therefore, she creates two versions of the report. List of on-hold products with a list of interested wholesalers for each product. List of wholesalers with a list of on-hold products that may be of interest to each wholesaler. Anna sends the final report to the person in charge of the meeting for review and comment. Tips for effective reports. The way you design a report will depend on the data it will include, the audience that will use the report for decision-making, and the way the data will be used. Reports can be as brief as a few lines of summary text, or they can be highly detailed spreadsheets or within datasheets with many rows of records. The key to building a useful report is communication, your communication with the audience that needs the report, so you understand them, and the communication of the information to the audience so they can use it. Effective reports should utilize the headers and footers of a report and its pages to aid the reader when navigating the report. Headers and footers should contain useful information such as the report title, author, and page numbers. This makes it easier for a report reader to quickly find the information they are looking for across multiple reports. Link to learning. Data is only good to the extent that it is both accurate and actionable. Raw data without any use is just clutter. With this in mind, watch this video on how to make data actionable and consider how reports can summarize large amounts of data and make that data actionable. The goal of a report is to eliminate as many individual lines of information as possible and to simplify information through summary wherever you can. In general, consider the following when preparing effective reports. Minimize line-by-line data. Use labels to explain the data that is shown on the report. Use formatting to designate titles and other labels. Incorporate whitespace to ensure readability. Test with possible audience members to be sure the report makes sense to the final audience. Focus on answering specific business questions generated by the person or people who request the report. Organizing a report. A report can be flat, with one record per line, or you can use grouping to further organize the data. When designing a report, think about organizing your data as follows: sorting to order your data by an important field, e.g. name when you are discussing customers or sales region. Grouping records based on a field such as active versus inactive products, regions that met specific targets versus those that are lagging in meeting goals, or geographical area. Totaling groups of data such as sales figures to show both the detailed figures e.g. and individual salesperson's sales figures and the figures for the overall region. Access will allow you to quickly add and preview sorting, groups, and totals to ensure the report communicates what you need it to for the audience you are working with. Creating and editing reports with the Report Wizard. WorldCorp is interested in creating a summary of their recent sales data for their latest product line. The report should include useful information such as which products have the highest total sales, which products have the highest net profit, and which customers are purchasing the most products. WorldCorp could create this report from a blank canvas, but it would be much easier to generate a report using the Report Wizard. This is a small program that will walk you through the steps of setting up a report, which you can then modify to meet your needs. Using the Report Wizard is usually an efficient and easy way to start a report. Most reports will need some form of customization, but the wizard will provide a good starting point and will save steps by adding fields that are bound to the database. Creating a report. To start a report with the Report Wizard, click on the Create menu in the ribbon and then choose the Report Wizard command from the Reports section. The wizard will walk you through each question before creating your report. Step 1. In Step 1, Figure 13:40, you can set the table S and/or queries you want to work on within the report. This gives you flexibility, as you can use data from more than one table or query in your work. Hint: consider setting up a query for your report before starting the report. This will enable you to check the data before setting it up for display. Once you have chosen and added tables, queries, and fields to the report, use the button to move fields to the selection box. Click Next to move to the next screen in the wizard. Report Wizard pane reads: which fields do you want on your report? Selections include table queries, query, product list with client information, available fields, product ID, selected fields, blank. Arrows visible between fields panes. Figure 13.40 The report wizard allows you to select fields to include in the report, used with permission from Microsoft. Step 2 and Step 2 Figure 13.41 You can choose grouping for your report. Skip this step if grouping does not make sense for your report. A group is a heading that organizes data with something in common. For example, you might group data based on the region a customer is assigned to. When used as a group, all customers belonging to a specific region will appear together. Once you set up grouping, you can click Next to continue. Report Wizard pane reads, do you want to add any grouping levels? Client ID selected. Product ID pane lists, client ID, client name, client mailing address all. Left, right, top, bottom arrows with priority in between visible between panes. Figure 13.41 In this example, grouping by product ID has been used, creating a report that first lists each product, with the client info of every client who has purchased that product listed under the product ID. Used with permission from Microsoft. Step 3 of the report wizard asks how you want to sort your records as Figure 13.42 shows. Access allows you to sort by up to 4 fields in the designated order. For example, to create a report that fits the needs of your audience, you may want to sort a set of records by sales region in alphabetical order and then sort further by product ID. Once you set up sorting, you can move to the next step in the wizard. Report wizard window reads, what sort order do you want for detail records? Panes available for populating. 1 displays client ID with ascending buttons at right. Next button selected at bottom. Figure 13.42 Using the client ID field with the report wizard allows you to sort records in ascending order from smallest to largest or from A to Z. Used with permission from Microsoft. Step 4 After you have set the sort order, the wizard will ask you to choose the layout for your report. Figure 13.43. You can also set the orientation and ask access to adjust all fields to make sure they fit on a page. Report wizard reads, how would you like to lay out your report? Step selected in layout, portrait selected in orientation. Adjust the field width so all fields fit on a page, selected. Figure 13.43 Setting the report layout in the report wizard allows for limited customization of the final report. Used with permission from Microsoft. Step 5 The final step in the wizard allows you to set a unique title for your report and then choose whether you want to provide the results or go into design to modify the report. Figure 13.44 Usually viewing the report will be useful as it will show you what you want to change. When you are done, click Finish to continue the work. Report wizard reads, what title do you want for your report? Product and then client with mailing info. Do you want to preview the report? Modify the report's design? Preview the report selected. Figure 13.44 Setting a name for the report is the final step before Report Wizard generates a preliminary report. Used with permission from Microsoft. Reviewing a report. When you double-click on a report in the navigation area, the report will open with current data displayed. Let's look at a simple report in Figure 13.45, a listing of all product categories. This report, named Product Category List, was created quickly by clicking on Create and then Report. Product Category List selected from queries in All Access sidebar. Report displays with header and columns for product category ID and description, populated with information in cells. Date time listed at top. Figure 13.45 The report generated by the report wizard is well organized and easy to read. Used with permission from Microsoft. The title at the top of the report shows the date the report was run, followed by 2 columns that list the product category ID and the description. This report is set up by Access and has not been modified. In Design View, Figure 13.46, this report appears differently with the design and grid available for modification. This report is usable as is, but taking a few minutes to customize it will make it more useful for your audience. Property Sheet button selected from Tools, Report Design tab. Property sidebar visible with search bar and tabs for Format, Data, Event, Other, all selected. 2 columns populated with selections for formatting follow. Figure 13. 46 Access allows you to fully customize the layout and content of a report depending on your specific needs. Used with permission from Microsoft. In Design View, the report header appears on the first page and includes the title and dates of the report. This is followed by the page header, which appears on each page and includes information useful to the report user, such as page number or report author. The report detail is the area where data from the database is displayed for each record. Each record will show the product category ID and description. The report has a page footer which displays useful information such as the page number and appears on each page. The report footer shares the number of pages in the entire report. As you build reports, you will likely switch back and forth between the report view and design view to change elements such as spacing and formatting so that your report is useful for your audience. Link to learning. Personal and company data needs to be safeguarded, and reports that summarize data related to projects and goals also need to be protected. Therefore, one of the responsibilities of anyone dealing with data and reports is data security. To this end, governments have put laws and procedures in place to guide how organizations manage data and reporting. This article on data privacy laws provides an overview of some of the laws in this area. Customizing reports. Although Access does a nice job of starting a report, you will likely want to modify reports before using them. Following are some of the changes you may want to make. Changing the size of fields, e.g., shortening them. Formatting the text of the report, e.g., by adding boldface. Shifting text boxes to lay the screen out more effectively. Page layout view. Page layout view gives you a simple way to make changes to the overall appearance of a report. Changes made to a field in page layout view will be applied to all fields of the same type, e.g., if you boldface a field, all fields of the same type will also be bold. Page layout view displays live data while you make your changes, which makes decision-making easier. To enter layout view, click on the View command on the Home tab while you have a report open on the screen. You can preview the report by changing to the report view. When you are finished working, save and close your report. Design view. The Design View screen has more options for customizing your report. To switch to Design View, use the View command on the ribbon. Design View gives you a layout grid for your form and the ability to move each label and field independently, change the formatting of the text, and even change the attributes for each element on the report. A common change in Design View is modifying the size of the field on the screen. For example, you may find that Access cuts off some of the label or content in a field. You can modify the size of the field or label by clicking on the element, and then using the selection handles on the left and right sides to stretch or shrink the element. You can also move elements manually by clicking and dragging them or by clicking on multiple items and using the commands on the Arrange tab on the ribbon. These commands allow you to move items up or down, arrange them together, or control how the elements are arranged on the report itself. Adding an image or custom text. You may want to include a logo or even a disclaimer as an image in a report. These images can add information or, as in the example of a logo, provide identification. Images typically appear at the top or bottom of a report. Remember that if you place an image in the details section of the report, it will repeat for every line. This is useful when you want to have each line start with a symbol or logo. To add an image in Design View, click on the Form Layout Design tab and choose the image that you want to add. You can also add any image to the page by clicking Insert Image, see Figure 13. 47, and then locating the image file. Again, be aware that when images are placed in the Details section of the form, they will repeat for every line. If you would like the image to appear only at the top or bottom of a page, place the image in the page header or footer. You may want to add elements that are not strictly images but display on the report, e.g., titles, dates, and times. Note that these items will be displayed on the report but will not be stored in the database. They will change each time you open the form. Insert Image button in Controls toolbar, Report Design tab selected. Categories in a form are displayed in Design View. Figure 13. 47. You can export selected Access objects to an Excel worksheet. Used with permission from Microsoft. When you create and modify a report, Access will prompt you to name and save it. Each time you modify an existing report and close it, Access should prompt you to save it. You can save manually by right-clicking on the name of the tab in the work area and choosing the Save command. To close a report that is open in the work area, click on the X next to the tab name. Learning objectives. By the end of this section, you will be able to understand why forms are useful. Create and edit a form using the Form Wizard. Customize a form by adding images and text. Relational databases are built on a structure of tables. Each table is made up of columns, which hold fields, and rows, which hold the information for each field for a specific record. This is an effective structure for the organization, but as the database becomes more complex and we use joins in queries to create relationships between data across tables, we need an easier and more manageable way to work with the database. Using forms to interact with our database tables has two benefits. Forms provide an easy way to interact with the database. Forms protect the data and underlying table structure from accidental changes. Most websites are based on databases and use forms to connect to the database. In fact, online shopping sites use a combination of forms, preset queries, and reports to create a positive user experience. Forms are the pages themselves, which allow us to search and retrieve information, e.g., a product listing, by running preset queries and returning detail in either a form or report format. When we look at a website, we do not see the underlying data tables. We see forms and the results of queries based on forms or formatted as results. Using forms in a database. Forms are objects that are positioned between the data and the individual user. When individuals work with a database using forms, they do not see the table structure with thousands or hundreds of thousands of records. Instead, they see only a specific view designed to make the data accessible and useful for them. Forms are typically bound to the database, which means that the fields within the forms are the same fields as in the database, and any changes in either the form or the table are reflected in the other. You can also create an unbound form containing buttons and commands that allow an individual to access the database, but that does not display any information. An unbound form is likely to be used as an interface to the database and can create a home page that makes it possible for someone unfamiliar with the database to easily access and use what they need. If you were going to build a database that was simple and used only by you, you might not need a form. Even so, a form would make it easier for you to navigate, interact with, and complete tasks. You could build a form that would let you automate tasks that you perform often, like updating inventory. For a single person accessing a database, forms make work more efficient, although they may not be critical to success. When a database needs to be used by many people, including some who are relatively unfamiliar with the database or with database technology, forms are a critical tool. They provide both an interface to the database and a way to navigate and access data that is pleasant to use, makes sense, is designed for the specific use case, and enables anyone to use the database while ensuring data integrity and security. The sales and marketing group at WorldCorp has asked you to set up a database that the team can use to look at sales figures for different time periods based on products. The team is not familiar with Access or with databases in general and does not want to spend time learning the technology. Instead, they want an easy-to-use interface that will allow them to search and retrieve summary data. You already have a database with all this information that is ready for use, but it was not designed for the sales and marketing team. You decide to create a form that will allow the team to add a date range and a product type, then return a summarized report showing the necessary sales. You build a form with this function and then add text that explains the purpose of the form and how to use it. Once the form is finished, you create a dashboard for the team that allows the team to choose this specific form by clicking a labeled button. After you have built and tested the forms, you alert them to the new function. This gives them a powerful new way of looking at sales data and retrieving the information they need, when they need it, in a format that works for them, all without needing to modify the database or its objects. Spotlight on ethics. Addressing data security risks. Employees who work with data need to be aware of data security and able to manage security issues. Nevertheless, many employees may not be aware of the risks that their behavior poses to personal and business data. Even as we work to increase technical security, Employees' irresponsible or unethical behaviors may put their own, their coworkers, and even the organization's data at risk. According to Forbes, risks to consider include the following: social engineering vulnerabilities, the risk of employees being tricked into revealing credentials or installing malware through tactics like phishing attacks. Unmanaged IoT devices, the challenges posed by the increasing number of unmanaged Internet of Things (IoT) devices which lack proper policies and controls. Lack of awareness. The risk associated with employees' inability to detect frauds, scams, and phishing emails, emphasizing the need for strong security awareness training. Data loss. The importance of adopting a data-centric approach and implementing data loss prevention measures to safeguard data and ensure compliance. Personal data accessibility. The need to ensure that customer data is only accessed by authorized individuals through proper security protocols. Managing the increasingly complex digital business environment. The difficulty in consistently following security rules in a growing and complex digital landscape. Insider threats. The significance of paying attention to insider threats and ensuring that employees and other individuals with access to corporate data do not misuse their privileges. Insecure applications. The risk associated with applications storing and transmitting sensitive data, especially through insecure application programming interfaces and third-party channels. Untrained end users. The vulnerabilities arising from employees who fall prey to phishing emails, download malware, or mishandle confidential data, emphasizing the importance of ongoing training. Consumer trust in data repositories. The impact of data breaches on consumer trust and the need for comprehensive asset audits and robust segmentation to mitigate such threats. Third-party risk. The importance of evaluating and securing third-party relationships to prevent data from being exposed to a wider network. Overestimating the ability of network defenses to ensure data security. The need to protect data within applications through encryption, authentication, and secure key management, rather than relying solely on network defenses. Misconfigured cloud servers. The risks associated with misconfigured servers in cloud environments and the need for automated security solutions to identify and remediate misconfigurations. Lack of data access oversight. The risk posed by granting employees and contractors excessive data access privileges, necessitating continuous data classification and auditing efforts. Addressing these risks is crucial for businesses to protect their data, minimize potential financial losses, and maintain customer trust and confidence. Types of forms. As mentioned, you might decide to create a form as a user interface or a form that accesses and displays information. A form that acts as an interface is likely to be unbound, meaning it is not connected to any specific table or database query, and to include a combination of text, images, and command buttons that access certain objects in the database. These forms can also include search fields if that function is valuable to your audience. In a bound form, the fields are linked directly to objects in the database. We use bound forms when we want to access data in tables or through queries. Remember, any modification to a field value in a form also updates the underlying data in the table. Here are some common forms that you can create in Access. Simple form, a form that displays and allows editing of a single record at a time. Split form, a form that has two functions. For example, it might display a single record as well as a view of the datasheet in which the record is held. A split form is useful when you need to see the larger set of data but work with only one record at a time. Multiple item form, a form that displays information about more than one record or item at a time. It appears like a datasheet but allows you to add commands, format text, and add other controls. Navigation form. A form that allows you to add formatting, text, and commands to act as an interface or navigation area for your database. These are typically unbounded forms. Tips for effective forms. Creating useful and effective forms requires a clear understanding of the data you have, the audience that will use the form, and the use case for the data. Good forms are more than just boxes on a screen. They demonstrate an awareness of how people will interact with the data and use it on a daily basis. A good form should anticipate user expectations and adapt to meet them. For example, using white spaces to separate information into useful blocks can make it easier for the reader to quickly navigate the form. In addition, you can use the form to control what users can enter into fields. Customers should not be able to enter in numbers as their name, for example. To ensure data integrity, you should consider restrictions on what can be entered into forms. If you are using free-form fields, those filling out the form could really put in anything they want, resulting in unusable data for your organization. Here are some tips for creating effective forms. Label your fields to the left or above the point where data will be entered or viewed. Do not use spacing in field names. Stack your fields on top of one another to increase readability. Mark required fields with an asterisk. When there are more than 5 or 6 choices, use a drop-down menu. Break forms into steps if you have many fields to fill in. Adjust field size based on the length of the answer. Keep related areas on the form together, e.g., all name fields should be together. Offer ways for people to get help, including instructions, email addresses, and phone numbers. Keep the form as brief as possible. Make sure the size fits the use of the form. Use white space, blank space on your form to help your users understand and work with the form comfortably. Test your form with different people in the target work group and on different technology when possible. Do test prints with PDF files to see if records will be visually attractive if saved. Creating and editing forms with the Form Wizard. You have several options for creating forms in Access. You can use the Form Wizard, which walks you through the steps to set up a simple form. Alternatively, you can use a preset form, or you can work entirely in Design View, where you have complete control over your layout and contents. Each method has its benefits, and many people use a variety of techniques, e.g., starting with the wizard or another type of form, then customizing your form in Layout or Design View. The Form Wizard gives you a quick way to create a form that you can later modify as needed. Like other Microsoft Office wizards, the Form Wizard asks you a series of questions and uses your responses to format the desired object. Creating a form. To start the wizard, click on the Create tab. Then in the Forms group, click on Form Wizard. Once the wizard opens, walk through each screen, making choices at each step to design and complete your form. Step 1. Choose the table S and fields you want to appear on the form. Move fields to the form by clicking on the button. Note: to use fields from more than one table, switch tables while on the screen and move the appropriate fields to the right using the button. See Figure 13. 48. Form Wizard asks, which fields do you want on your form? Table queries displays table, product category, available fields blank and selected fields description display right and left facing arrows between panes. Figure 13. 48. Using the Form Wizard, you can select fields to include in your form, used with permission from Microsoft. Step 2. Choose the layout you want for the form and click Next. Columnar layout shows a single record set up on the screen. Tabular layout creates a listing of all records in columns, similar to a datasheet but formatted differently. Datasheet layout gives you a list of records as they would appear in a datasheet. Justified layout creates a record-by-record form, arranged across the screen. Once the form is built, you can modify it to ensure it looks the way you feel is best for your data and audience. See Figure 13. 49. Form Wizard asks, what layout would you like for your form? Options listed: columnar selected, tabular, datasheet, and justified. Figure 13. 49. You can modify the layout of a form using the Form Wizard. Some data will lend itself to one format over another, used with permission from Microsoft. Step 3. Enter a unique name for the form and choose whether you want to see the form in Design or View mode. Click Finish to create the form. Forms can also be built from any table or query or a combination of both. One way to streamline setting up a form is to set up a specific query with the fields you want to be displayed on the form. Once the query is ready, you can do the following. Click on the table or query from which you want to build the form. Click on the Create menu, then click the Form command. Access will create a form and open it in Layout View for review and modification. Using the More Forms command. If a simple form does not provide what you need for your database, consider using the More Forms command on the Create menu. This command offers 4 form types built directly on the table or query you click on in the navigation pane. To use the More Forms command, click on the table or query on which you want to base your form in the All Access Objects navigation area. Click on the Create menu and then the More Forms command under the Forms section. Choose the type of form you want to work with. Access will immediately create the form, which you can then modify to suit your needs. See Figure 13. 50. A list includes multiple items, datasheet, split form, and modal dialog with icons displayed. Figure 13. 50. You can select the type of form you wish to create using the More Forms command, used with permission from Microsoft. Reviewing a form. Regardless of the method you use, once your form is created, you can view it either in View mode, which shows how your audience will view the form, or in Layout View or Design View, which allows you to modify the form. See Figure 13. 51. To change your view, click on the Home tab and then on the View command. Under the View command, choose one of the following: Form View, to see how the audience will view the form. Layout View, to modify the layout and formatting of the form. Design View, to modify any and all attributes of the form. List displays Form View, Layout View, and Design View with icons. Figure 13. 51. As with viewing reports, there are 3 different options for viewing a form, used with permission from Microsoft. The forms that Access builds can be used as is, but you will often want to add to a form or slightly adjust its formatting. You can do this in 2 views: in Layout View, which allows you to change the overall layout and formatting, and in Design View, which allows you to change any attributes in the form. When you edit a form in either Layout View or Design View, you will have the ability to work with fields and controls. Fields are columns within the database where data is stored. You can add and remove fields from your form to ensure that you display the data you need to your audience when they work with the form. Fields in the form reference field values in the database and display information from the database. When you are in Layout View, you can see this as you work. In Design View, you will see the design elements but not values. You can also add controls to a form. Controls are items that are part of your form and can enhance its usability. Bound controls are connected or bound to a specific field, table, or query in your database. Unbound controls are not tied to the database but exist only in your form, where they run a specific command or action or display specific information. Some common controls in Access include text boxes. See Figure 13. 52. Labels, buttons, and links. Each of these controls adds functionality to your form. You can add a command to open a form in Design View by clicking on the specific command in the Controls group on the Form Design tab in the ribbon. Depending on the control you add, you may need to work with the control wizard, complete a screen, adjust properties, or complete the control on screen. When you begin working with forms in Access, you may work with the control wizard and then preview the form in the View menu to see how the control works in practice. Various icons displayed: arrow, lowercase abel, italicized AAA, rectangle, tabbed file, 2 linked ovals, slanted line, white box, green checkmark, bar graph. And set control defaults. Use control wizards, ActiveX controls. Figure 13. 52. Adding controls to a form can be easily done with the control wizard, used with permission from Microsoft. Note that in Access, a text box is typically linked to a field in a database. To add static text to a form, you should instead use a label. Labels do not change on the form based on the data within the database, unlike text boxes. Customizing forms. In both the Layout View and the Design View, you can customize elements of the forms to meet your needed. This goes beyond simply adding, reordering, or removing fields from your form. You can change the size of the field and the caption that the users see for that field. In the Design View, you can change the size of the fields by simply clicking on the field box and resizing the box. To change the caption for the field, double-click on the text in the field, and the Properties Sheet screen will appear on the right side of the screen. Conversely, you can simply click on the Property Sheet tool in the Tools command group on the Form Design tab to change the captions. Through the Property Sheet tool, you can also adjust items such as the font, color, background color, and border of the fields in the form. You can adjust these settings for each field independently. This means that one field could have different settings than another field. More is covered about the property sheet options in the following section. You might want to add header or footer information to your form. Typical information contained in a form header would be specific company details such as the company logo, address, and contact information. WorldCorp has standard header information that should be included on all files as was covered in previous chapters. This information is customized on the form through the Form Design tab and the Header-Footer command group. You can have text, images, and the date and time added to the header. This information can also be added in the same manner to the header. To adjust the text, simply click on the existing text in the header or footer and replace with the text you want to include. Note that Access will give a header to the form based on the name of the table used to create the form. You will likely want to replace this header with something more descriptive. For example, if you are creating a form based on a table called Sales Data, the form header will be Sales Data as well. You could replace that with something like Sales Data for Region 3, 2023. In summary, customizing forms in Access is similar to customizing reports, which we covered earlier in this chapter. You can generally customize just about every aspect of the form from the font to colors to adding images and other related aspects. Layout View. The Layout View screen gives you a good look at your form with real data showing on the screen. This enables you to modify the screen's visual appearance, including the size and placement of controls. Not all tasks are available in Layout View. Depending on your goal, you may find that you need to change to Design View. To modify a form in Layout View, start by opening the form in Layout View. Then, proceed as follows. To add a field, click on the Format tab in the Controls group, then click Add Existing Fields and drag the field to the form. To move a control, click on any instance of the control and drag it to a new location. Note: you will have limited options for moving a control. To resize a control, click on the control, select its border, and click and drag until it is sized properly. To add an image to the page, click on the Insert Image command on the Controls group and choose the file. Once the image is on the form, you can move and resize it. These are only a few of the options available to you in Layout View. To see more options for customizing your form, hover over the command on the ribbon and read the description. Remember, what you see on screen in Layout View reflects the final form, making it easier to set up a form that meets your needs and has the appearance you feel works best for your data and your audience. Design View. If you find that you need to make changes to a complex form, you will likely want to switch from Layout View to Design View. The Design View screen gives you complete control over the appearance of the form but is more complex to use. You may want to use Design View for tasks such as moving elements and controls, adding images, adding simple controls, and changing form properties. In Design View, you will see tabs that control how you lay out the form. You may also see floating menus and boxes that appear depending on the items you click on. The Design tab contains commands that control the overall design scheme, colors and fonts, controls you can add to the form, and commands that allow you to insert items and change properties of items on the form. The Arrange tab contains commands that allow you to line up items, insert, move, and arrange items, and manage the layout of items on the page. Note: this tab may not be available unless you select more than one item, such as an image or a control. The Format tab contains commands that let you format the text on the form and add background images and formatting. To move items manually, click and drag them or click on multiple items and use the commands on the Arrange tab on the ribbon. To move a single item, control, image, text, click and drag the item. To move more than one item, hold down Control, click on each item and then move all of them at once. Adding an image. It can be beneficial to add an image, such as a logo, to a form for customization. You may also create a text explanation or block of text in a graphics program and then insert it into the database as an image. To add an image in Design View, click on the Form Design tab and choose the image that you would like to add. You can add any image to the page by clicking on Insert Image and locating the file. Be aware that if you insert an image in the Details section of the form, it will repeat in each row. To add a logo, click on Logo in the Header-Footer group and the image will appear at the top of your form in the header. In addition to images, you can also add a title or date and time in the header-footer section of the form. These items will be displayed for your users but will not be stored as data in the database. Changing form properties. Properties describe how a form control or field acts in a form. Form controls determine how the form works. There is a long list of properties that you can control. Initially, you will likely only change basic properties such as the width of a screen or the addition of scroll bars, see Figure 13. 53. To change a form property in the Open Form, click on the Command Property Sheet Form Design Tools group. The property sheet will open. In the property sheet, verify that form shows as the selection type. Modify the properties you would like to change and click on the category of property you would like to work with, e.g., you might want to format items on the form. Here are a few examples. To add a caption to the form, click on the Format tab within the property sheet and add caption text. To change the default view, click on the default view and switch the type of form. To control the width of the form, set the width in the width row. Property Sheet selected Form Design tab. Property Sheet sidebar displays all tabs selected. 2 columns follow listing form items at left and selections at right. Figure 13. 53. Each form contains a number of properties that can be edited and customized depending on the purpose of the form. Used with permission from Microsoft. When you create a form or modify an existing form, Access will prompt you to name and save it. You can save manually by right-clicking on the name of the tab in the work area and choosing the Save command. To close a form that is open in the work area, click on the X next to the tab name.